electric field intensity due to infinite line charge. This is one of the very important topic from the EMF. So here we have to find electric field intensity. Electric field intensity due to infinite line charge. Infinite line charge. So electric field intensity due to infinite line charge, the standard equation explains rho L by 2 pi epsilon r into unit vector. Right? So this is the standard equation, standard formula here. Electric field intensity due to infinite line charge. Now we have to derive this equation using Coulomb's law and using Gauss law. So two different procedures are there. Using Coulomb's law and one more procedure is using Gauss law. So first of all, we will go through the using Coulomb's law. So Coulomb's law, from the Coulomb's law, electric field intensity standard equation is defined like this: dE is equal to differential electric field intensity is equal to dQ by 4 pi epsilon r square into unit vector. That unit vector I am writing like this, U12, right? So dE is equal to dQ by 4 pi epsilon r square into unit vector. This is the standard electric field intensity equation from the Coulomb's law. Now in this equation, first of all we have to find dQ. First of all we have to find out dQ, change in charge, and later we have to write a unit vector, that is U12, unit vector, and later distance. Later we have to substitute all these values in this equation, then we will get this equation: electric field intensity due to infinite line charge is rho L by 2 pi epsilon r. So to derive this equation purpose, first of all I am taking one infinite line charge. The charge is distributed on the line, the length of the line is infinite. Then immediately we have to take a line charge density. Rho L explains the line charge density, right? Total charge by length, right? So for that purpose, here I am assuming one coordinate system. The coordinate system which consists of x-axis, y-axis and z-axis. Rectangular coordinate system I am taking now, right? So this axis x-axis, z-axis, and this is y-axis. Rectangular coordinate system. Then from the given topic here, electric field intensity we have to find out. Electric field intensity is nothing but the force acting on unit positive charge. The force acting on unit positive charge. So for that purpose, I am placing that unit positive charge on x-axis with certain distance here. This distance is, I am assuming here, r. This distance is r, right? From here to here it has some distance. This is r here. Now I will write this formula here, capital R, right? So from origin to this point, the one point is located here. This point is located on x-axis with certain distance. Then the point becomes here, r comma, x-axis coefficient r comma y comma z. So x coefficient is r and y coefficient is 0 and z coefficient is 0. So then the point is r 0 0. Then the vector equation of this is r into ax direction. R into ax, right? And electric field intensity due to infinite line charge. Now we have to take infinite line charge. The charge is distributed on the line. The length of the line is infinite line. Now I am placing that infinite line length charge on z-axis. See, this is infinite line charge here, right? So the charge is distributed on this line like this, either positive charge or negative charge. The charge is distributed on the line. The length of the line is infinity line, minus infinity to plus infinity, which is defined from minus infinity to plus infinity. It should be like this. That infinite length of the that infinite line charge I am placing on z-axis now. I am placing on z-axis. Now the z-axis limits are from minus infinity to plus infinity. Then we have to find the force acting on this point due to this infinite line charge here. So directly from infinite line finding force is not possible. That's why here I am considering one differential length here. So here I am assuming some differential length, right? From this point to I am finding here force on this point here. The force on this point. From this point to this point. That's why there I have assumed differential length dl. Then we can write total charge equation. What is the total charge now? dq is equal to general equation explains the rho l into dl. Rho l into dl, because the line the charge is distributed on the line. Then we have to write line charge density. Line charge density is total charge by length. Then the total charge dq is equal to rho l into dl. Differential length. Now I have placed this infinite line charge on z-axis. That's why here I am writing that dl is equal to dz. So directly we have to write like this, rho l into dz. This part also finished. And later we have to find out unit vector. To find the unit vector, first of all we want here distance vector. Distance vector. So the distance vector is from this point to this point. This point vector is already defined. What is the vector here? R into ax. R into ax. Ax is a unit vector that explains direction. And what is the magnitude here? R. And this differential length I have assumed in particular distance. That distance is now I am taking here z. Then the point of this is 0, 0, z. The point of this is 0, 0, z. Then what is the vector here? Z into z is there. In which direction? Z direction is there. That's why we have to write like this, z into az. Then one vector is here z into az and this vector is r into ax. Now we have to find out the distance vector on this point. Then immediately it gives the this vector minus this vector. So distance vector r12 is equal to one vector is rax minus another vector is here zaz. So this gives the distance vector. This vector is also finished. And later we have to find out unit vector. So what is unit vector? Unit vector explains the distance vector by magnitude of that, right? So distance vector by magnitude of this vector. That purpose I am writing this one now. R into ax minus z into az by distance magnitude. Magnitude means here we have to write like this, square root of r square plus z square. Finally, which gives the unit vector here. So unit vector is finished and dq also finished, and later we have to write this r here. R is nothing but magnitude. This becomes again square root of r square plus z square. Substitute all these equations in the standard equation here. So dE is equal to dq. What is dq here? Rho l into dz by 4 pi epsilon r square. Here r square is there. R is nothing but this one. Square root of r square plus z square whole square into unit vector u12. Unit vector is this one, right? So right here r into ax minus z into az by square root of r square plus z square is there. So I have substituted all these parameters in this. Then we have to simplify that. For simplification purpose, here we have to find out capital E is there. So but here D is there, differential electric field intensity. Then we have to cancel the D part here. To cancel the differential purpose, we have to apply integration on both sides. Integration on both sides. Which type of integration? One time or two times or three times? That means line integral or surface integral, volume integral. That is depends on this one. So this is only one parameter is there. So line integral is enough, right? So apply both sides line integral. Apply line integral. Line integral on both sides. So now we have to apply line integral on both sides. Then it becomes here E. electric field intensity E is equal to, this cancels, and here constant terms I'm writing outside, constant terms are here 4 pi epsilon, 1 by 4 pi epsilon, these are constant terms, and rho L is also constant, right? Line charge density, that is also I'm writing outside, and the remaining part I'm writing like this, line integral. This line integral with respect to which axis? Z axis, with respect to Z. And Z axis limits are here from minus infinity to plus infinity, because that line charge is here, we have to take infinite line charge. So Z axis limits are from minus infinity to plus infinity, minus infinity to plus infinity, dz by, so here r square plus z square, root is there, and here root is there, and whole square also there. That's why directly I am writing now r square plus z square whole square, and here 3 times is there, so 3 by 2 I am writing directly, and into unit vector r into ax minus z into az. Now from this I am assuming here az part is 0 here, az part is not considered, because see here I wrote this vector from this point only, but what we have to find out here, the electric field intensity due to infinite line charge. So due to this complete charge we have to find the electric field intensity on this point. Whenever some force acts on like this, acts on this point like this, and similarly another force acts from this side also is there. That's why finally this axis and this axis, these two are cancels here. Just I'm drawing here like this. Infinite line charge is here, and one point is located here, right? One point force acts on this point, it should be in this direction, and similarly some other force acts from this side, negative axis side, then it is in this direction. Then what happens here? This direction and this direction both are cancels, then finally which gives the resultant direction is which direction? X direction. That's why unit vector, the z direction representation is not assumed, so not required, that is 0, because here the line charge is placed on z axis, that's why z direction it does not give. So az part is 0. If az is 0, then the remaining equation becomes here E is equal to rho L by 4 pi epsilon, line integral from minus infinity to plus infinity, r into dz by this r I have wrote here, r square plus z square whole power 3 by 2 into unit vector in which direction? Ax direction. Now this part we have to simplify here. To simplify this purpose, internally two variables are there, one is r and another is z, but this integration is defined with respect to z representation, then we have to equate those, right? So to equate that purpose, here again I am taking this diagram. So this length is z length and this length is r length. Now this is a distance here. So these three just like acts as one right angle triangle. From this here I am assuming angle is here. So one angle is defined like this. From that I am writing one standard equation, tan theta is equal to opposite side z by adjacent side r. Now then z becomes r into tan theta. So now I want to replace z with this equation, z is equal to r into tan theta, then the complete equation in terms of r, then simplification is very easy. Then immediately you have to replace this one also, dz also, right? That purpose apply both side differentiation, then it becomes z dz into r into secant square theta d theta. So dz also replacement is required, so dz apply both side differentiation, then dz becomes r into secant square theta into d theta. Then the complete expression is defined in terms of theta representation, so theta limits also changes. If the z value is minus infinity, then the theta becomes minus 5 by 2. Substitute in this, z is minus infinity we want here. When it becomes minus infinity, if the theta is minus 5 by 2, and similarly z is infinite, the theta value becomes plus 5 by 2. Now I am replacing the complete form in this. Electric field intensity is equal to rho L by 4 pi epsilon. The integration is changes from minus 5 by 2 to plus 5 by 2, because now the integration is with respect to theta is there, and this r I am writing as it is by and r square plus here z is replace this one, then it becomes r square into tan square theta whole power 3 by 2 and replace dz with this complete equation r into secant square theta into d theta. In which direction? Ax direction. Then simplify this. Take r square common from this. So if you take r square common, then r square and here 2 is there, so 2 get cancels, then it gives the r cube, and in numerator r square is there, r square by r cube becomes 1 by r. So rho L by 4 pi epsilon r is I am writing outside, and the remaining part minus 5 by 2 to plus 5 by 2. Here secant square theta is there, 1 plus tan square theta. If r square theta is common means if it is outside, then the remaining parameter becomes here 1 plus tan square theta. 1 plus tan square theta is secant square theta. So square this 2 cancels, secant cube theta is there. Here secant square and here secant cube, then it becomes 1 by secant theta. Just simplify that, then you will get this one. 1 by secant theta with respect to theta. 1 by secant theta is nothing but cos theta. So this is acts as cos theta. Integration of cos theta is minus sin theta. So sin theta, right? Then write that one, rho L by 4 pi epsilon r, right? Integration of cos theta is sin theta. Apply the limits from minus 5 by 2 to plus 5 by 2. So plus 5 by 2 substituted here, sin 5 by 2, sin 5 by 2 value is 1 minus sin minus 5 by 2 minus 1. So 1 minus of minus 1 becomes here 2, then these 2 cancels, direction also there, write the direction as it is. So 2 get cancelled, finally which becomes here rho L by 2 pi epsilon r with direction ax direction. This is electric field intensity due to infinite line charge. Electric field intensity due to infinite line charge is rho L by 2 pi epsilon r into unit vector. Here rho L is line charge density of that infinite line charge. So line charge density, r explains the distance from this charge, line charge to this point here. So if the distance is increases, electric field intensity is decreases, so both are inversely proportional here. R and capital E both are inversely proportional. Line charge density is increases, electric field intensity is increases. Now here we will get this direction, unit vector direction is ax direction, because here I have assumed that point on x axis. If you take that point on y axis, then it gives the ay direction. If you take that point on xy plane, then it gives the x direction and y direction. That is depends on the point assumption. It's okay, point position. That's why here I have wrote AR direction, that is depends on the point position. This is one of the standard formula, electric field intensity due to infinite line charge. Here I have derived this complete equation using Coulomb's law, and similarly we have to derive this complete expression using Gauss law. So if you want to derive any expression using Gauss law, immediately we have to take the total enclosed charge is equal to surface integral of d dot ds equation. And if you want to derive any equation from the Coulomb's law, then we have to take this equation, d is equal to dq by 4 pi epsilon r square into unit vector. So please take this now.